Alright, so this tutorial is for drawing ray diagrams for reflection and refraction of various rays in various materials. In this case, we have a very simple one. We have one ray of light going from air into water. The first step when we're going to draw this is to first draw our normal. Our normal is the perpendicular line right above the surface. So I'm going to take my protractor, place the 0 mark on my boundary, and then we're going to draw in a normal. Okay, I'm going to draw it above and below because we're going to need to use the above part for reflection, the below part for refraction. And by convention, this line will be dashed. Okay, so your dashed line is your normal there. And we can have that be something like that. Next thing I'm going to do is measure my angle of incidence. That's the angle between the normal and the ray that will tell me how this light is actually hitting there. So I'm using my protractor up against my normal now because every single angle I measure has to be from that normal. I'm going to make it a little bit bigger so we can see clearly the angle here. And in this case, it looks like it's about a 48-degree angle. Okay, and we call that the angle of incidence between the normal and my angle, or my ray. Okay, now that I know my angle of incidence, I can look at my reference tables and see that theta I equals theta R. The angle of reflection is equal to the angle of incidence, which means whatever angle I came in at, I'm going to bounce off the same angle. So I'm going to spin my protractor around here, and I'm going to draw a ray that goes through that 48-degree mark. 50, 48, something like that. And we'll make it a red one so we can see that clearer here. There we go. And that is the angle of reflection. And we drew in our reflected ray. Okay, so reflection is pretty straightforward. Angle it comes in at is equal to the angle it goes out at, and all you have to do is remember to measure your angles from that normal. Okay. Now, the refracted ray is a little bit different because that's not going to come off at the same angle. To do this one, we're going to need to add some math in, and this is Snell's law formula. I look up air and water from your reference tables and see that the n value for air is 1, the n value for water is 1.33. So n1 sine theta 1, this is the angle of incidence coming in, the 48 degrees, and n2 sine theta 2, that's the angle coming out, my angle of refraction, which I'm now going to have to draw in. So again, we take our protractor, we'll expand it out a bit. Okay, and again, I'm measuring these angles from the normal. So I need to draw a 33, 34 degree angle, meaning that we're going to have our ray start and come out at a 33 to 34 degree angle, somewhere right around there. All right, now in this case, again, I'm not drawing the angle from the boundary. All the angles have to come from the normal. Okay, so there is my angle of refraction down here, and my refracted ray right there. All right, so things to remember for drawing ray diagrams: draw your normal first, perpendicular line to your surface. You measure every single one of your angles from the normal, and the equations that you would need in your n values are all found in your reference tables.